Welcome back, students. Today we'll start with new chapter, that is data handling. Here we'll study what is data handling, what is the need to organize data, central tendencies, graphical representation and chance and probability. In this video we'll study what is data handling, data organizing and some.
Let's get started. Now before starting, we'll see what is meant by data. Now imagine some alien has come out of space by spaceship, and this alien is asking what is human height on earth. Now how will we answer that? We have complete population of almost 7.5 billion people on earth, and how will we represent all of their height in one number? Now I know this doesn't look anything like earth, but imagine if this looks like earth, then people live everywhere across here, everywhere, and everywhere there is different particular height. So how will we do that? So let us assume that this is the complete population of the earth. Okay. Now we'll remove alien and spaceship out of the picture. Now this complete collection of height of all the human beings on earth is called population. Now this population can refer to anything. Now when I'm saying anything, I literally mean anything. That means this thing can refer to, in this case it's referring to human height. It might refer to marks obtained, number of people, number of pets, types of houses, anything that you want to analyze. Here we want to analyze human height. So what do? We take out few sample data from the complete population. Now this is called sample. And the sports player, increase or decrease of any particular object. So after collecting data, what we would do is we would analyze all of these things. Maybe this is what we are collecting data for. These are all examples. What we can do after collecting data? We might be able to predict what will be, for example, performance of a particular student in particular subject in next exam, because their till date average performance has been X, for example. Okay, so this we can do using collection of data. Now let's see why would we want to organize our data, right? Let's take an example that in a particular school authorities wanted to paint over old canteen, and they gave 3 themes to the students: mythological characters doodle, cartoon based doodle, or inspirational people based doodle. They gave these 3 choices to their students and asked their opinion which theme would they prefer in canteen. Class captain of each class was supposed to collect everybody's preferences and give to school authorities. And the most popular theme was going to be applied in the canteen. To ease out the process, what class captains together did was they took a piece of paper and color coded the choice of their classmates. For example, if this was class 7th A, the class captain wrote choices of his classmates in this way. Now one look at this piece of paper will not give you how many students from this class want which of these themes. Alright, so According to this piece of paper, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 people who want mythological character based canteen theme. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 people want inspirational people based canteen theme. And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people want cartoon based theme. So which one is most popular in this class? 11, that is inspirational people theme, is most popular in this class. In this way, if we organize every data that we have in some easier representable way, it will be easier to take inference from it. Inference, that is conclusion from it. Now, these are the students of a class arranged roll number wise. 1, 2, 3, 4, 5 roll number, and these are the marks obtained by them in mathematics out of 50. Now, one look at this list will tell you that Ashish is highest in these 5 students. But if I had something like 50 students, would it be that easy to determine which one is highest student? No. So what we do next is we arrange these students by marks obtained in them. Marks obtained by them. Highest going first. Highest here is 48. Then comes 35. Then 30. Then 25. Then 23. Something like this. So now it's easier to know who obtained the highest marks and who obtained the lowest marks. This is why we organize the data and then it becomes easier to read the data. Next is arithmetic mean. Now we saw central tendencies. Let's revisit them. Arithmetic mean can be calculated like this. Mean is equal to sum of all the samples divided by number of samples. Now it's very easy to learn formula. X bar is equal to summation of xn, that is x bar means mean of all values of x, is equal to this symbol means summation. This here means summation. Summation of xn, that means x1, x2 till xn. That is all the samples. Summation of all of n samples divided by number of samples. That is this last value n. That is not the value, not the sample. Number of samples, this n. Okay. Now, बहुत हो गया formula का description. Let's solve some problems. Now this is the question. Ashish studies for 4 hours, 5 hours and 3 hours respectively on 3 consecutive days. बाप रे, बहुत पढ़ता है. I hope my students are also studying. Okay. How many hours does he study daily on an average? That means we have to calculate average of these 3 values. Applying this formula, that is x bar is equal to summation of xn divided by n. So what is xn? 4 hours. 4 plus 5 plus 3 divided by how many samples? 1, 2, 3. So divided by 3 equal to 4. 4 plus 5 is 9 plus 3 is 12 by 3, which is equal to 4 hours. So he is studying 4 hours on an average daily. Now next is this question. A batsman scored following number of runs in 6 innings. Calculate the mean runs scored by him in an inning. Again, x bar equal to summation of xn divided by n. Here summation of xn is 36 plus 35 plus 50 plus 46 plus 60 plus 55. That is addition of all of these runs. Now all of this divided by 1, 2, 3, 4, 5, 6. That is 6 is number of samples equal to 36, 35. That is 282 divided by 6, which is equal to 6 4s are 24. 4 remains. 4 2 6 7s are 42. So he scored 47 runs per inning on an average. So I hope you are getting the hang of this, how to calculate average or arithmetic mean. Did you observe from these two examples that the average, this number, does not always lie on given sample values? That is, 47 is not one of the given sample values, but yet average value is 47. In last example, Ashish studied for 4 plus 5 plus 3 hours. In these 3 sample points, we had 12 by 3 equal to 4. So this average was one of the sample values. Okay, but in this case, this average number was not one of the sample values. So what we can say is, the average or arithmetic mean may not always be one of the sample points. So these are the 2 points we learned about arithmetic mean. Range of data. I think you can tell what the meaning of this quantity might be. Range means कहाँ से कहाँ तक value lie कर सकता है. If I am saying height of students in class 7, height of students, तो it can't be 0 feet, right? 0 feet का कोई student class 7th में नहीं रहेगा. For that matter, 1 feet का भी कोई student class 7th में नहीं रहेगा. कहाँ से कहाँ तक रहेगी उनकी height? Maybe 4 feet से लेके 5.5 feet तक, right? So this is the range of height of students who are in 7th standard. Okay. And to calculate the range of given data, we need to have the given data organized in either ascending or descending manner. So the difference between highest and the lowest observation of given data is range of the data. Okay, and for calculating this range, what we do is we just subtract first value from last value. That is, if we have arranged these values in ascending order. So this is basically lowest value and this is basically highest value. So first value जो भी होगी, when we subtract from this last value, we get range of this data. And if we have arranged it in descending order, then what do we have here? We have last value subtracted from first value. This value subtracted from this value will give us range of this data in case of descending arrangement. Okay, so You will first arrange the given data and then you will calculate the range. Let's start with problems. The ages in years of 10 teachers of a school are these. What is the age of oldest teacher and that of the youngest teacher? What is the range of the ages of the teachers and what is the mean age of these teachers? So to calculate all three of these, what do we need? Oldest teacher and youngest teacher. What is the range? Range निकालना है. And then what is the mean age? That is average age. So let's first organize this data in ascending order. Youngest is 32, 41, 23 seems to be the youngest. So 23. Then we have 23. Then we have 26. 26. Then we have 28. 28. After that we have 32. 32. After that we have 33. 33. Then 35. Yes, 35. Then is there any 30? Yes, 38. Then we have 40. Then 41. Then last is 54. No need to cancel it out, but yes. So that you don't get confused with other numbers, whenever you are writing one number, just cancel that number out from given list. Okay. I have taken these numbers over here, and next we have to calculate what is the age of oldest teacher and that of the youngest teacher. Oldest is 54, that is we have arranged this in ascending, so last number is oldest and youngest is 23. First number will be youngest teacher. So what we've done here is arranging data in ascending order. Then we get answer to first question, that is 54 years is age of oldest teacher. And similarly 23 years is age of youngest teacher. Now in second question what we have to calculate? The range. So range of the data, what we do is this last sample minus this first sample. 54 minus 23. Range is equal to 54 minus 23 is equal to 31 years. This is the range of given values of ages of teachers. Okay. What is next question? Next is what is the mean age of these teachers? Very simple. You add all of these and divide it by 10. You can do it. Answer should be 35 years. Try. Now this is enough for today. Solve first and second exercises, both exercises from NCERT book. These are based on arithmetic mean and range. We'll start with the other two central tendencies, that is mode and median, in next video. See you.